Welcome to Numbers with Nicole. Today we're going to find the missing side of a right triangle using trigonometry. So here's an example of a problem that we might encounter. So in order to use trigonometry, what is trigonometry? We mean sine, cosine, or tangent ratios. So what are those ratios? This image here came from mathisfun.com. They're a great resource, so you can go on there and do some fun math things. Okay, so we know that the sine, the cosine, and and the tangent of an angle depend on this Greek letter that we have right here, theta. So that just represents an angle. And so the sine, the ratio of sine is opposite side over the hypotenuse side. And that is true for every triangle. Every time you take sine, you are comparing the opposite side over the hypotenuse side of that right triangle. And the ratio, that sine to hypotenuse, depends on the angle. So if we have two right triangles, they could be different sizes, that each have an angle of 30 degrees, the ratio of that opposite over that hypotenuse side will always reduce to the same amount. Okay, so we're going to use these ratios, sine, cosine, and tangent, to solve for an unknown side in a right triangle. So sine, we're going to use SO as our acronym, and that is always the opposite over the hypotenuse. For cosine, we're going to use ca, and that is our adjacent over our hypotenuse. And for tangent, the tangent ratio is always the opposite over the adjacent, so we're going to use TOA. So these are our acronyms, how we're going to remember those ratios. Sine, O over H, cosine, A over H, and tangent, O over A. O for opposite, A for adjacent, H for hypotenuse. Remember, O and A depend on your reference angle. So let's look at an example. Goal again is to find the missing side of a right triangle using sine, cosine, or tangent. So when we look, if we're given information, maybe we have to draw a diagram and label it. Here we are given one. Then we're going to write down our acronyms. So, ca, toa. So I've done that. And now I'm going to look at what I've been given and identify what information I have. So here's my reference angle. Across from that, or opposite, is my x value. And then we have our longest side opposite that 90-degree angle, our hypotenuse. So which of these ratios, sine, cosine, or tangent, has opposite and hypotenuse in it? That is sine. So now we're going to write our equation. The sine of the angle, which is 42, equals the ratio of the opposite, which is x, over the hypotenuse, which is 18. So now how do we solve this? We're going to take our ratio here and we're going to put it over 1. We're going to take our trig thing, our sine of 42, and put it over 1. And now this looks like a proportion. And how do we solve proportions? We can cross multiply. Another way to think about it is we want to get the x value by itself. So in order to do that, the opposite of dividing by 18 would be multiplying both sides of the equation by 18. So now once we're here, we're going to just go right over to our calculator, which should be in degree mode, sine 42. I'm just going to check real quick. Yep, degree is highlighted. 18 times sine of 42 is 12.04, blah, 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 blah. And it says to round to the nearest tenth. So 12.0 is x, or the opposite side. So let's look at another example, another model that we can do here. So we're going to find the missing side of a right triangle. Our unknown is going to be in the numerator. So I'm going to write katoa down. I have a diagram, so I don't need to do that. All right, so now we need to look at the diagram and identify what information they gave us. Here is my reference angle. All right, across from that, or opposite from that, is x. And now if I look adjacent to that, is 34. I know it's not my hypotenuse. That is the longest side, which cannot be your opposite or your adjacent. So O and A, that would be tangent. Tangent of 63 degrees is equal to the opposite, which is x, over the adjacent,